Welcome to .NET Mastery. My name is Brugin, and in this short video, we will take a look at Crosssite, Request Forgery, and AntiForgery tokens with .NET Core. Crosssite Request Forgery is an attack against the web-hosted application where a malicious web application can influence the interaction between a client browser and a web application that trusts that browser. These attacks are possible because web browser sends some type of authentication tokens automatically with every request to the website. Let's take a look at this with an example. So here we have Dan who is surfing his banking website and he enters his credentials and hits the login button. The server authenticates the user and issues a response that includes an authentication cookie. This site is prone to attack because it trusts any request that it receives with a valid cookie without checking if the request was originated from the same origin. Now let's take a look at how this scenario can be exploited. So let's assume Dan is surfing his computer, but this time he comes across a malicious website. Let's say he got an email and he opened this email with this malicious website. Here the website is asking for some details and it is displaying that you won an Amazon gift card. So Dan gets excited and he goes there and enters his information. But you can see that they have an hidden attribute in this bad website where they are going to his original banking site when user posts the data. Inside the form action, you can see it is actually redirecting to the good banking site and it is adding a method of post there with some transaction and amount. This good banking was the same bank where Dan was browsing earlier and hiddenly they are doing a withdrawal of let's say $1 million. Now when Dan submits the information and hits the continue button, the browser makes that request and automatically includes the authentication cookie for the requested good website domain since it is still valid inside the Dan's browser. So as soon as he will hit the continue 100% free, the request will actually go to the bank server with the credentials from the cookie and it will perform any actions that the authenticated user, which is Dan in our scenario, is allowed to perform. These alternative scenarios do not require any action or input from the user other than initially visiting the malicious website. This is how Crosssite Request Forgery attack takes place. Now let's try to understand on what conditions these attacks are more exploited. Firstly, the GET requests that change states are insecure. A best practice is never change the state on an HTTP GET request. Then the cross-site request forgery attacks are possible against a web application that uses cookies for authentication, because these cookies are stored on the machine which can be exploited as we saw. This condition can also be exploited when multiple applications are hosted at a single domain. Let's say we have two domains. First is example1.cost.net and the next application is on example2.cost.net. Since both of them share the same server, these attacks are possible. One thing to remember is the CSRF or the cross-site request forgery attacks are fundamentally a problem with the web application and not the end user. Now we have the basic understanding of what the cross-site request forgery is, what .NET Core provides to prevent this. Starting with ASP.NET Core 2, we have AntiForgery Token. So .NET Core 2 forms tag helpers inject AntiForgery Token into the HTML element. This AntiForgery Token is applied by default. If the form is not GET, the following markup will automatically generate an AntiForgery token. So if you just use the form tag helper with method HTTP post, it will automatically generate an anti-forgery token. That token is generated, but we need to make sure that inside the controller we have notification that valid anti-forgery token is present, only then proceed further. That being said, now that I have talked about anti-forgery token, but what exactly is this anti-forgery token and how does that work? First, the sender sends a token associated with the current user's identity to the client. Then the client sends back the token to the server for verification. Finally, if the server receives a token that does not match the authenticated user's identity, the request is completely rejected. And this functionality is automatically integrated with .NET Core to prevent cross-site request forgery. So there are a few things that you should remember. First, in getRequest, you should not alter the state, and if you are using the form attribute with tag helpers, you do not need to worry about anything, because .NET Core will automatically add the anti-forgery token on top of authentication. But there is one small thing that is still needed, so it's best to take a look at all of this with an example. Now, in order to see the anti-forgery token in action, we will have to create two new projects. So first, we'll open up Visual Studio 2019 and we will be creating an MVC application. You can select MVC from the option. I'll just create it right here. The first application I will call this as Bank Application. Let me hit next here, .NET 5, no authentication. Let me just enable the Razor runtime compilation and create the project. This will be a very simple application. Inside the views, we have the index view and we also have home controller right here. So first thing, we want to change the index view. Right here, I just want to add a form with a method of post. Right here, let's first consider a very basic scenario. Like we have an input with the type of text and name, we will give that an account number. I have added a placeholder here. If you want, you can create a model and bind this view to that model. In order to do that, we just need to create a model inside our models folder. Let's add a class which is bank account. Here we will create two properties. We'll make both of them as integer. First is the account number and next one we'll call it as PIN code for the account. Then inside our index view we can have that as the model here, which is bank account. So rather than name here, we can use the ASP4 tag helper, which will be account number. We will copy this and let me paste that one more time. Next we will get PIN code from the user. This will be for PIN. Finally, we will have a button which will have class of BTN, BTN primary, some bootstrap classes, type of submit, and we will display update. So let's imagine we have a page in our bank account where user can enter their account number and PIN, and the new PIN will be updated. PIN can be treated as password. So what we will do is inside the home controller, we have the index action method. Right here we can copy and paste a new action method which will be for HTTP post. So whenever we hit the submit button inside the index, it will go to the action method which is HTTP post. We don't want to do anything fancy here. Let's just display the account number and PIN that the user posted. So right here we will receive an object which will be of bank account, and rather than returning view, we can just return content to keep things super simple. Let me use string interpolation and I will say account. We will have the account number which is inside bank account dot account number has been updated with new PIN, and we will write the PIN here which will be inside bank account dot PIN. Perfect. Let's run our application and see if everything works. Right now, I do not want you to worry about security aspect. We'll keep things simple. So we'll enter both the details and perfect. It says account 111 has been updated with the new PIN. So that's working. Now in the next video, let's see the cross-site request forgery in action. Now we know the URL of our main bank application is 44303. Let me make it a little bit simple. Let me stop the application. We will go to the properties here. Inside the debug tab, we can set the profile of bank application, and we have localhost 5001 and 5000 for HTTP. So rather than running in IIS Express, let me select that profile here and run the application. That will make sure that now my application runs on a different URL, which will be 5001. So perfect, the application is running on 5001. Let's create a new project which will try to hack the bank application project. So let me create a new project here, the same MVC project, and I will call this as Bank Hacker Project. Inside this project, we will have the index view as well inside the home folder. We will modify a few things right here. Let me remove everything that we have here. We will add a div with a class of row. In there, we'll add a div with a class of column 12 and text center. Here in the first paragraph, I will add some dummy lorem ipsum text, and then let me create a form here and add a new paragraph, and let me add the same dummy text. This dummy text is of course not required. Our main focus is on creating a form. For this form, we will have a method of post, but where should it post? This is a bad application that will try to hack our bank application, which is running on localhost port 5001. So let me copy this URL, and that will be the port right here. So action, we will explicitly define that as HTTPS localhost 5001, and then inside home controller, we have the index action method. If we go back to our main application, you can see inside the home controller, we are updating the PIN number, let's say inside this post action method. So the bad application is pointing to the same path of our good application. And let me minimize the bad application right here so you can see both of them. Inside the good application, we had the account number and PIN. So inside this form, let me add the first input for PIN. I won't be creating a model. Let me just use the basic one. Then I can copy and paste that one more time. Next time, we will be account number. Now, of course, placeholder here is not required because we won't be displaying this. It will be inside a hidden property. The name, we will have to call this as account number. And then type here will be hidden, so we can just cut this from here and paste it instead of the type. Then right here, we will also have a button. We will give that a class of btn primary. And let me give that a type of submit. And here we will display click to claim your price. What we want to do in this bad application is when someone clicks this price, we want to change their PIN and account number. How do we do that? We can provide a fake value here of PIN, let's say 111, and account number, let's say 555. Now, if this scenario does not make sense, that's okay. I'm not walking you through a real-world project of what you can hack and what you cannot. I just want to explain you how someone from a different URL can do a cross-site request forgery attack. So with this in place, let me go back to our application, which is bank application that is running on port 5001. Let me run the bank hacker application. It is running on a different port as you can see. Think of this as a website where they display that you have $100 of Amazon gift card. Click here to claim your prize. As soon as you click here, what's gonna happen? If your bank has not implemented security, and let's say you are logged in, so the details will be saved in your cookie. So when you click on claim your prize, you can see it actually was able to update the account number with the new PIN of 111. This should never happen because the request was coming from a different URL or a different port. This is something that application needs to be protected from. How can we protect this and never let this happen in our application? Let's take a look at all of the protective measures in the next video. So one way to protect our main application from cross-site request forgery attacks is with the use of AntiForgery Token. In order to use that, let me stop the main bank application project here, and we will go to the home controller, where we have the HTTP post action method. .NET Core provides a new attribute, which is validate AntiForgery Token. With that, let me run the application and try the attack one more time. Let me switch back to the hacker application that we have, and let's click the button one more time. This time you can see it redirects to that URL, but it displays this page is not working. So our post action method was not called because we had the attribute that valid AntiForgery token must be present. Since this is coming from a different URL without the AntiForgery token, the bank application already knows that this is not the request that I should process, and it just throws it away. With the new AntiForgery token that we added, if we inspect the element, and let's try to inspect our form. If we expand this, you will notice that there will be an input with the name of Request Verification Token. Its type is hidden, and this token has been added automatically by .NET Core in our bank application project. The hidden field here represents the authenticity of the form generated because the backend action requires it. When the form is submitted, this token is also passed to the backend behind the scenes, and the validate AntiForgery token header validates this value for authenticity and allows the submission to happen. So on the bank application, if you try to change your account and PIN, that would work. But with the cross-site request forgery, it won't work. Because in this other scenario, if we inspect the element and if we inspect the form right here, you will notice that there is no AntiForgery token that is present. So when the form gets submitted, the action method receives no such token and it is automatically rejected. This way, submission cross-site is restricted by the AntiForgery token attribute. We can place this AntiForgery token attribute inside the controller's action method, or we can directly place that at the controller level as well. So you can remove the validate AntiForgery token from there, and we can place it at the home controller. And other than validate AntiForgery token, we also have one more attribute, which is auto-validate AntiForgery token. This applies the AntiForgery token concept to all of the methods except HTTP GET action method. One advantage is that we can use this attribute to add this as a global filter as well. How do we do that? That we will be doing inside the startup class file, where we are adding controllers with views. Here we can configure options. So we can say option goes to, and we can add option.filters.add, and what we want to add is new auto-validate AntiForgery token attribute, and you'll have to press Ctrl dot to add the using statement. That will add this at the global level. So you can see there are multiple ways in which you can add the validate AntiForgery token in your application. So with this in our short video, we have seen how the bank application was prone to attacks without the use of validate AntiForgery token, and how that helps us solve the cross-site request forgery attacks. So thank you for watching this video, and do not forget to subscribe to the channel. And for more videos and courses, always go to .NETmastery.com.